Alright, so for question 6, we have the strict line equation L1 and L2, that is in terms of m, where m is a constant. And they're saying that L1 and L2 cut the y-axis and P and Q. And they're saying that L1 and L2 intersect at one point at x on the x-axis. So the graph should be looks like this. So let's say this is L1, and then they cut the x-axis at point P. And there's another line, L2. So it cut the Q, but they are going to cut with the L1 at the same as the x-axis. So now we're trying to find out what is the length of this PQ, which means we need to find out what is the value of P and Q, actually. So now, because they are intersect at the same x-axis, same points, isn't it? So we're going to try to find out what's going to be their the intersection point. So if you don't want to find out what is the x-axis, that's the x-intercept, then we need to substitute y to 0. So for the x-intercept, we need to substitute y equal to 0 into L1 and L2. So for L1, we can say that's going to be mx plus m minus 1 times 0 plus 20 equal to 0. Because the x, the y should be changed to become 0, we keep the x. We're trying to find out what is the x-intercept. So now I have the mx plus 20 equal to 0, then x is equal to negative 20 over m. So this is the value of L1, okay? So now for L2, we're doing a similar thing. We have m plus 1x, then minus m minus 3y, plus 24 equal to 0. Still substitute y equal to 0, so the whole term here is 0. So now I have m plus 1x equal to negative 24, so the x is equal to negative 24 divided by m plus 1. So as they are meeting at the same point at the x-axis, so that this x-intercept should be the same. So now we can say that the negative 20 over m should be equal to negative 24 divided by m plus 1. So now I use the cross method because both of them have negative, so it becomes positive. I have 20 times m plus 1 equal to 24 times m. 20m plus 20 equal to 24m. So now I have 20 equal to 4m, so that m should be equal to 5. But now it's not finished yet because we're trying to find out the PQ's coordinates as well. Let me write it here. Now we can say that the L1 is equal to 5x, and then I plus 4y plus 20 equal to 0. I just change the m, and m plus 1 becomes 5 and 4 respectively. And then now we have the 4y should be equal to negative 5x minus 20. Y is equal to negative 5 over 4x minus 5. So minus 5 should be our the P point. So for L2, I have m plus 1x, that's going to be 6x minus m minus 3. So I'm going to need 2y plus 24 equal to 0. So 2y giving you 6x plus 24. Y is equal to 3x plus 12. So now positive 12 is going to be the value of Q. So you can see from here, so this is going to be the Q, which is 12. This is going to be the P, which is negative 5. So distance between there is going to be 17. The answer should be C.